Good morning, everyone. Welcome to another episode of XA Talk Show. Today is 2019, January 8th, Wednesday, 3 o'clock in the afternoon, San Francisco time. And according to schedule, the topic schedule, we are supposed to talk about Golang today, but I'm not sure what topic to talk about Golang. You see, this is my XA Talk Show homepage. So today is Wednesday, and Wednesday we have it marked down as Golang. So, but I'm not sure. So let's go to topic brain. Okay, let's go to talk show page, and let's go to topic brain, where this page is my random notes about possible topics. And let's search for Golang, and so let's call the command list matching lines Golang, and you can see we have actually several topics about Golang. In fact, we have actually we do have some topics about Golang, so let's go there. Let's search for Golang. So I think we are going to do some Golang live coding for a while. Then we are going to talk about random stuff. So Golang. So here are some topics about Golang. Go fix print lines. Use a xah git find replace go. Okay. So that is one topic about Golang. Let's do it then. Golang, lots of topics, and find replace. Let's modify this a little bit. Find replace script. Okay, so refresh, you can see Golang fix print lines. So find replace script. Oh, so this is my Golang script. It's on my website, and this is the URL. It's under xah-find-output. You can find it and use it. So this script is for doing find and replace for thousands of files in a directory. And perhaps we should show a demo of it. In fact, I did a demo of these several times in my video, but let's do it again. Okay, before we do anything, let's check I'm alive. Yes, status Houston, I'm alive, and I have 5 people watching. Okay, let's do Golang. And after Golang, I do have some topics. Let's go, let me show you. Okay, after Golang, I do have some topics that I want to tell you about, which is about arts and emacs workflow. Okay, but let's do Golang first. So let me show you what is this Golang script is about. This is about find and replace. Okay, let me think of a actual real world task that I need to do for find and replace. Okay, I have some idea. So I'm going to do a demo of Golang right now, and let me show you what. Let's write down what we are doing. Okay, so live stream Golang demo and live coding, and modify the find replace script so that it prints there's something I need to fix, but let me remember what is it. So hold on a second. Copy the URL back to Emacs, paste it here, and linkify so that we have the URL for you guys to look at. And go back to the page. So Golang find and replace find string. So we are going to demo of that, and so we need to modify it so that it prints list of files in separate lines. Okay, that is what we are doing. That is what we are going to do. So let me show you. So here it is, today's first topic. And so first of all, I'm going to show you what this command do. I'm going to do a real life demo. So in order to do that, let me go to my JavaScript website. So yesterday we did a talk show about JavaScript where I modify my JavaScript tutorial navigation boxes so that they become one coherent tutorial box like you are seeing right now. So for example, you can go to iterable. So this section is about JavaScript iterable. You click on that, you go to the JavaScript interface page, and you scroll down, and you can see the entire table of contents there again. And you can see the green is highlighted, is the current page. So we did that yesterday. But we are here today because I want to find something I need to do a global find and replace for hundreds or thousands of pages. So let me look for what I want to do. There's some thing I want to change here. So JavaScript basics, variable, string, function, object property, object and inheritance. Okay, there is something constructor and class. Okay, let's say rejectsp. Okay, you see that word rejectsp. Let's change it to regular expression. Yeah, let's change it to regular expression. So the table of contents page is right here. That's what you are looking at. So this highlighted text corresponds to this navigation box. So let me magnify. So, and let's search for REGE. Okay, here, rejectsp. So that part corresponds to this part. Okay, and we are going to change that, copy that here. We are going to, okay, let's start the Golang script. So open a new window, we want a new window. Okay, so new window, let's bookmark. Let me show you here. So let's set background color to seashell. Okay, and let's go to xah bookmark, xah open file fast. Then let's type replace. So you see we have a replace goal. So this is my Golang script for find and replace, and we are going to use it. So first of all, what directory we want to work on? The directory will be this JavaScript directory. So I go to here, copy the file path, go back to the Golang, select that, paste, and remove the file name. So this is the directory we want to work on, and we want to work on all HTML files, and we want write to file true, do backup true, backup suffix tilde tilde. Okay, that's all good. And what is the find and replacement we want to do? So that part is over here. This is where you enter the find and replace string. So the find string will be that. Okay, go back here. So the find string will be that. Okay, and the replace string will be, let me show you. The replace string will be regular expression. Okay, so here is the replace string. Now if I press a key to run this script, then it will go to work and it will change all the regular expression to the word there. So hi Mr. Yemen. Yemen, what are you talking about? Speak English, not ghost language. So okay, so now let's run the script. Let's change background color again. Okay, gray. Okay, set background color gray. Something gray 9. Oh, that's no good. Set background color gray 99. Okay. So I'm going to run the script now. Let's see, regular expression. Let's just run it. Okay. xah run current file. And whoops, what the fuck? Syntax error, unexpected expression, expecting comma. Oh, this is really unexpected. Did I? Oh, okay. So I made a mistake. You see, I deleted this back tick. You see, the back tick is for quoting. It's for quoting string. Let me show you. So wait, let's go to Golang page, my Golang tutorial showing browser. And if you have not learned Golang, this is a great tutorial to get you started. So you go to Golang tutorial, then you go to string, then you can see the normal syntax for string is double quote. And then you in Golang you have also a raw string, literal, and that is done by using the backtick quote. So now let's go back to our code. You see, so therefore we have the backtick there and over here. So now let's run it again. Run. Fantastic, it's working. You see, I have quite a few files, hundreds, about 500 files. That's gonna. Okay, it's done. Now go back here. So you can see here are all the files that has changed. That's correct, or in the JavaScript directory. Now if we go to the JavaScript file, my JavaScript tutorial, if you refresh, you will see this change. Let's refresh. Do it. There it is. Regular expression. Fantastic. So that is a demo of this Golang find and replace script. So Golang in general is about 6 times faster than any of Python, Ruby, JavaScript. So, and it's pretty simple, so I highly recommend it. It's about the same speed as C or C++, Golang. Okay, so now we have done this, we have demonstrated this find and replace script. What's the next thing? Okay, you see here, you see it says find and replace pairs. Now this is the output of that script. Now let's look at the output. So the output, the first line is declaration of encoding. Okay, and so you see this is kind of a emacs convention. This is how you declare the encoding of a file, and this convention is also adopted by Python and Ruby. Let me show you. So copy the Golang tutorial. Let's go back to let's close the JavaScript. Let's post what we're doing here. So you can see this is today's topic. And now I'm going to show you, we are talking about, so this is the Golang output. Okay, and the first line is the declaration for the encoding. And this line also includes a declaration of mod, like what major mod to use when you see this file. This is convenient because, so if Emacs open this file and Emacs sees this line, then Emacs will use the UTF-8 encoding to open this file to decode the file, and Emacs will start the xah-find-output major mod. Right now, the mod is not, what is the current mod? Shell output mod, I think. Yeah, so for example, if I save this file, xx today's date, a random name, okay, save it, close it, reopen it, you can see how file names are highlighted. Now, what is causing that? That is because we are in xah-find-output mod, and you can see the mod name in the mini buffer, in the mod line there. And besides highlighting, it also allows you to jump to the file. For example, I can press enter. Oops, never mind that. So anyway, so this is the output of the Golang script. But meanwhile, good morning, Senze. So this is the output of the Golang script, find replace script, and we are talking about the first line of declaration. So let me tell you something about that. Okay, so xah-li Python tutorial. Okay, wait, let's go to xah-li Unicode. Okay, so click on the first result, and we have xah-li Unicode. Then you scroll down all the way, then you go to Unicode for programmers, and here is the index of all the articles I have related to Unicode for programmers, because they talk about technical details such as how to process Unicode. What does UTF-8 mean? What does encoding mean? What does all this Unicode mean in technical detail? What's a code point? And also, how do you declare encoding in HTML, in Python, or in Java? Or how do you process Unicode string in Java, in Python, in Ruby? It's all here. Okay, so now let's go to Python Unicode tutorial. Okay, let's open it in a new tab, and let's open Ruby Unicode tutorial. Open it in a new tab. Then let's go to Perl Unicode tutorial. You open a new tab. So basically, I have, and also there's a JavaScript, Unicode in Java. I don't care about Java. So let's see, JavaScript. I have tutorials about how to deal about all Unicode related issues in Python, in Ruby, in Perl, in Java, in JavaScript, in Mathematica, and others. But what I'm doing here is to show you the Unicode declaration thing, this convention. This convention is from Emacs, but it is also adopted by Python, by Ruby, as you can see, and by Perl. I'm not sure Perl use this convention, but it doesn't hurt if you add it. So anyway, so why do I have so many articles about Unicode? Let me tell you this. Okay. Good morning, Carson. So what are the issues of Unicode? Hold on a second. What are the technical issues you have to know when you work in a programming language related to Unicode? Let me tell you. Okay, first of all, programming, you have a source code. That source code, any file, needs a file encoding. So that is one first issue. What is the source code? What is the encoding of the source code? Right? So we are digressing, but that is good because I'm going to tell you something about Unicode. So we are in a recursive digression. So let me write down what we are talking about so it's easy to understand. So first of all, let me tell you Unicode declaration, file encoding declaration convention. Okay, that's one thing we are talking about. The other thing is, what are the issues of Unicode in a programming language? Okay, what are the issues? The issues are, let me tell you, the encoding of the source code. Now, any programming language, you have a source code. Once you have a source code, which is a file, if it's a file, it needs encoding and decoding. That is fundamental. Good morning, welcome. Good morning to UK. So the issues of Unicode in programming languages. So I'm telling you. So the one thing you need to know is about the encoding of source code. For example, what encoding is allowed or required for programming language X? Okay, that's one example. And how do you declare such encoding? If the language allows various encoding, allows a choice of encoding, then how do you declare such encoding? So that's an example of the things we are issue. So encoding of source code, that's a thing, and does it allow any encoding, or it just allow one encoding? For example, in many languages such as Java allows only one encoding, that is UTF-16. Only that. You cannot have the file encoded in any other encoding. JavaScript, for example, there is no such requirement. But however, JavaScript is actually pretty complex. The encoding depends on the web technology, on server headers, things like that. Anyway, Ruby, for example, allows different encodings. You can have Ruby source code in UTF-8, in UTF-16, in UTF-32, or in a Chinese GB16 something encoding. So Ruby allows multitudes of encoding. Python 3, for example, allows only one UTF-8 encoding for the source code, nothing else. Okay, so that's some examples about file encoding issues in a programming language. Now, for some languages such as Ruby and JavaScript that allows multitudes, different choices in encoding, then you have a question about how do you declare the encoding. For example, Perl also allows many different encodings for the source code. So then you have the question, how do you declare it? Okay, so that's one example of the question about Unicode in a programming language. So I have tutorial, for example. So this page tells you about all the issues related to Unicode in Python. Okay, so let me paste it. So if you like to read it, you can. And actually, let me also copy this page. So for xah marketing purposes, makes my website more popular. So you guys can go read it. So we have Unicode, Ruby Unicode, then we have Perl. Okay, so once we started to talk about Unicode, there are 1,000 things to talk about. So we digress. Okay, so file source code encoding is one of the issue related to Unicode with a programming language. That's just one thing. The second thing, let me tell you, the second thing is string. String. String is one of the most fundamental data types in any language. In Perl, Python, Java, Ruby, basically all languages. String. You have to deal with strings. And string, when it comes to string, that's the heart of Unicode, because you are dealing with characters. So the question is basically, the general question is, how does your language deal with Unicode, emoji or math symbols or Chinese characters in a string? How do you deal with it? How do you can you, first of all, for example, can you actually have an emoji in your string? That's one question. Can you or can you not? So processing strings, Unicode strings, that is the question. How does your language process Unicode strings? And this subject is actually fairly complex. This subject is actually more complex than file source code encoding, because when it comes to strings and characters, different languages, they have different approach. They have different meaning of the word string. For example, in JavaScript, string is sequence of 16 bytes. Very strange. Okay. I can explain that. If you want me to explain that, I can explain that. So, the general question is, how does your language deal with strings? And different languages have very, very, very different approaches. In JavaScript, for example, string is a sequence of 16 bytes. 16-bit bytes. It'll take half an hour to explain that. Okay, that's JavaScript. In Python 3, a string is a sequence of Unicode characters. Okay, Unicode characters. Now, what does character mean exactly? That takes another half an hour to explain. So in Python 3, a string is a sequence of Unicode characters. Okay, in Python 2, a string is a sequence of bytes. Okay, that's very different. Okay, in Golang, a string is again a sequence of bytes. But however, Golang then Golang have byte slices. Then they have run slices. It's all related to Unicode string. Okay, so my point here. So and emacs lisp, for example, emacs lisp string is just a sequence of Unicode characters. Okay, similar to Python 3. in JavaScript, I mean in Java, for example, Java, a string is again a sequence of 16-bit 16 bits bytes. Very strange. So we talked about, so these are the things about, so the general question is, how does programming language X deal with strings, for example? And for example, in general, different languages have completely, totally different approach on what string is, on how to deal with strings. Okay, for example, what is a string? Okay, in JavaScript and Java, a string is a sequence of 16 bits values. Okay, in Python 3 and emacs lisp, a string is a sequence of Unicode characters. Okay, and by the way, what is a character? That's an interesting question. You know, as human animals, we know what is a character, but you see, the point about programming languages is that you have to define it specifically, very precisely. What exactly mean? You mean what is a character? Like, there's the glyph. Is it a glyph? Is it font? Is it what is it? So different programming languages, they have very specific meaning of a character. For example, in Golang, a character is just a Unicode code point. It gets complex. So essentially, in Golang, a character is just a number, basically a integer. So in Golang, a string in Golang and Python 2, a string is a sequence of 8 bits bytes. Okay, so that's some of the interesting issues we are talking about. Again, the overall, what we are talking about overall is the issues related to Unicode in a programming language. So I'm listing some of the issues, all of the issues actually. I'm going to list all the issues. So we started to have people here. Good morning, Bart. Why such a calm voice? Well, this is melodiousness, Xah Talk Show, melodiousness edition for a change. Good morning, Kathy. Sweet Kathy. And Namsu. So can you name variable in Chinese using Unicode? Yes, that's the next issue I'm going to talk about. A fascinating topic about all the issues of Unicode. So we talked about one file source code encoding. That's one issue. The second one, we talked about string, the question of string. What is it? Can you have emoji in a string? Can you or can you not? What does a string mean? Let me show you an example. Hey, good morning, Court Cook Patrick, and thank you, and good morning, Matty, and good morning, Sushi. So I'm going to explain 16 bits, okay, in a moment. Remind me if I didn't. So I want to thank you, Court, for donations, okay, big donations. So Court has been donating me via Patreon for half a year or so or more. So thank you, Court. So okay, so we are talking about Unicode issues in a programming language. What are the issues? Source code encoding, and how and how do you declare it, things like that. Then string, what does it mean? Is a string very complex. Let me show you an example. For example, let's this is a common example. JavaScript. Okay, let's begin JavaScript. Let's say let's okay, magnify console.log a string t. Okay, length. Okay, and equals to 1. Run it. It says true. You see the character, a string with the one single character is length 1. Now let's say tt, run it. Oh, it's 2. Okay, so actually let's remove that. Run it. So it says 2, obviously. But let me show you this. Okay, let me show you. Let's try this. Okay, hot. You see, we have a hot here, guys. Hot. So the result is 1, as expected. But let's try something else. Rocket. Okay, so we don't have rocket. So let's try emoji. Oh my god. Oh my god. Okay, this character. You see this Unicode character. Oh my god. Let's magnify for the dramatic effect. So this character, if you in Emacs you call describe character, you can see. So this character is that one, code point 128514, and the character name is faced with tears of joy. Okay, so that's that character. Now we're gonna run it. Okay, run it. 2. Jesus. So it says in JavaScript, it says this character has a length of 2. Now do you see the weirdness, the strangeness of it? So why does that? What's going on? Is it a bug? Well, technically, it's not a bug. With respect to human, it is a bug. But according to technicality, if you go by nerds, the bunch of nerds, Linux nerds, JavaScript hippies, they tell you what to do. They tell you you should use this idiom. You should follow this convention. If you don't follow, they they flame you. Those people, if you ask them, they will say, "Oh, this is natural because technicality, like the Linux thing. Whenever something doesn't work in Linux, the Linux fanatics will tell you, "Oh, that's because the kernel, because you are missing a screw in the kernel. You just need to put that screw on, and it's all good." So that's technicality of the nerds. So in this case, by technicality, this is actually correct. Why is it correct? Because no, it's not about type conversion. It's because JavaScript string, by definition, the meaning of string JavaScript is that it is a sequence of 16 bits bytes. Okay, wait, a sequence of 16 bits. Okay, or put it in another way, it's a sequence of 2 bytes. Okay, anyway, 16 bits, that's one unit. Another 16 bits, that's another unit. That's what it means. That's a technicality. That's a technical definition of string in JavaScript. Now, to explain that, okay, so hold on a second. Clear that and show in browser here. So if you actually want to understand that in detail, I can show you. You just go to xah-li JavaScript string. And similarly, you can search for xah-li Java string, xah-li Python string, xah-li Ruby. You might find some articles. So JavaScript string, and to explain this in detail, actually will take 20 minutes something. So for example, in here, character code unit code point. Okay, so on this page I explain what's going on. What does JavaScript string means. Actually, let me show you. Maybe there's another article. Let's just go to string. Okay, string overview. Yeah, you'll find. Okay, so actually let me turn on JavaScript. So you go to Xali JavaScript in-depth JavaScript tutorial. Then you first page about string is string overview. JavaScript in-depth. Okay, you guys buy it. Okay, Xali buy JavaScript tutorial in-depth. You'll learn. After you read this tutorial, you'll be a JavaScript expert. Better than all the hackers who tells you what to do about in JavaScript, because their information is often wrong. So anyway, JavaScript tutorial, then you go to string, then you have string overview. So on this page I tell you what is a string in JavaScript. String is first of all a primitive type, primitive value, and string is immutable in JavaScript, and string is 16 bits unit sequence. Okay, that's the technical meaning. And then I talk about string escape sequence and Unicode escape sequence. So when you deal with strings in Unicode, actually things can get quite complicated. It takes some effort to really understand them well. Normally if you are a programmer, you don't know that deep, because string is just a bunch of characters. That's all you that's most people all you need to know. Well, for me too, for the first 10-15 years of programming, I code a lot of text processing, but I never understood. In fact, it's almost like I don't need to. You don't need to understand the details until you run into some bug, such as that the length of a cat head is 2. Then you go, what the fuck? Then you started to read, and then ASCII characters and Unicode characters, the code points and sequences and bytes, and then it starts. Then you start to learn all the details. And once you know details, it does clarify the whole thing. For example, Python 2 versus Python 3, as you know, it's a big drama. Python people, they want to switch to Python 3, but actually a lot of people are not switching because this or that. And first of all, and why do Python wants to switch to Python 3? Why is Python 3 created in the first place? Why? Oh, why? Why does the Guido create such a complexity? Why? Because strings. String, exactly, string. Because the Unicode, they need to change. They want to make the language cleaner in dealing with Unicode strings. And this is the number one, the core reason Python 2 becomes Python 3, because they need to make the string deal with Unicode properly. And to this day, some people do not agree it's a good change. There are some expert Python programmers who believe that Python 2 is actually better, all things considered, when dealing with Unicode than Python 3. So anyway, that's an example of how complicated these strings in Unicode can become. So anyway, in this article, JavaScript string overview. So you look at, string is a 16-bit Unicode sequence. Then you click on that for detail. Then you can see an example we just showed before. And I explained them, in detail here. You can read. So let me just post. Let me post the link here. So if you want to know the detail of that, and go back, copy and paste. Okay, and show in browser. So we digressed a lot, and all is good. Good digression. Good digressions. So we talked about actually a lot about Unicode. So back one level, let's summarize. So we were talking about the issues of Unicode in a programming language. What are the issues? Source code encoding. That's one issue. How do you how do you deal with Unicode strings? What does a string mean? That's a second issue and the most complex issue. Now the third issue. The third issue is, for example, can you have Unicode in your in a variable name or function name? Let's show an example. Can you? So the question is, can you have Unicode in a function name? Why do you need that? You want that because let me show you. Okay, so let me show you an example. Let's say JavaScript. Okay, JavaScript again. We can use Python or emacs, Lisp. We can use a lot of languages. Let's do emacs Lisp. Okay. So emacs Lisp. Let's show. So define a function. So we have a function here. Now I want, let's say this is a function of pi. Now in mathematics there is a function named pi, named prime pi. Okay, I think prime pi, that gives you the number of primes under n, something like that, or nth prime. Okay, I forgot which, but let's look up the web. Prime pi. Okay, so prime pi is a function in Mathematica, and it is also a common name in mathematics. So prime pi gives the number of primes, number of primes less than or equal to 2. Okay, you see that? So in conventional mathematics, the function is named just pi. Okay, by in math notation, in conventional mathematics, in math books, for example, number theory books, you have this function named pi, and that gives you the number of primes, the count of how many primes under x or equal to x. But in Mathematica, they name it prime pi. So you see the function name. This is math tradition. Okay, you want a function named pi. So I want a function named pi. Okay. So for example, I can say that. Okay, hold on a second. Too big a font. It's pi. Okay. You see, I'm defining a function of pi gives the number of primes equal or less than n. Okay, less than or equal to n. Okay, that's what it does. And let's just say return 3. Okay, I'm too lazy to code it. So you see, that's an example. This is a example where you want to have a Unicode character as part of the function name. And besides that, there are many reasons. Okay, but my point is that sometimes it is pertinent and useful, very useful. You do want have Unicode in your function name or variable name. So we are in emacs. Actually, this works. So we run the code. Then I can just call it. Okay, let me show you. Let me show my emacs. Okay, so you can see my command call on the left window. So I'm going to do meta x. Okay, actually, let me modify this. Yeah. read number. Okay, give a number. Let. Okay, so actually interactive. Okay, this is getting more and more complex. So, and let's just say return 3. So this part is actually reading, ask user to give a number. So we can run the program, run it. Then I'm going to do meta x, and I'm going to type pi. Okay, type pi. Okay, you see in the mini buffer. Let me see if I can magnify. You see, meta x, I'm giving the function name pi. Enter. Symbols variable is void. Okay, I need to fix the code here, but let's not do it. My point here is that in emacs lisp, a function can have a Unicode as its name. That's my point. Okay. We need to fix this code later. Okay, so my point is in emacs lisp, a function can have a Unicode name. But this is not necessarily so in other languages. In fact, there are a lot of complexities. So let me show you an article then. So you can just search for example, this article. Unicode in function names and operator symbol. This, Unicode in operator symbol is especially useful. So, for example, the question we want to ask are: does your favorite programming language 1. support literal Unicode in string? That is, can you have a smiley in a string without using escape, incomprehensible backslash and a bunch of numbers, right? So can you actually have a Unicode in your string? That's one thing we want. And support literal Unicode in source code. That is, for example, can you have a literal Unicode in source code, such as in comments? Some languages cannot allow that. Then, does your language allow function names or variable names with Unicode in it? And we have an example there, And does your language allow non-letter Unicode in identifier? Okay, so what does that mean? You see, in many languages, they allow some Unicode characters in variable or function name. Only some of it, not all. For example, in many languages, if you want a function named like that, vector circle plus, you cannot do it. However, if you use the Greek letter phi, then it works. For example, this is a case in JavaScript, and this is also the case in Python, for example. In emacs lisp, both of them are allowed. So what's the difference? The difference is that in some languages, when they have a rule about what is allowed character in identifiers, variable name or function name, and they allow Unicode, but that Unicode must be a character. They allow Unicode characters, but that character must have a Unicode property in a category of letter. So if you have a Unicode such as this circle plus, which is not a letter, then you cannot use this character in function name or variable name. But however, if you have a Unicode character that is for example, the Greek phi or the gamma, then you can use it in function name or variable name. So you see, the issue becomes complicated. You see, different languages, they have different ways to deal with this. And this rule, where does this rule came from? I mean, this rule about how a Unicode character must belong to the category of letter. That's one of the property of Unicode. So if they belong to the category of letter, then you can use that character in function name. Otherwise, you cannot. This rule came from Unicode because Unicode Consortium, the organization that created Unicode, they have a bunch of guides, about what to do. So one of their guide is about this rule. So that's why Python, JavaScript, they both adopted it. It's and actually this rule is not good. Why? Because, for example, the vector, you see this operator, you see that circle plus. That circle plus is a very common mathematical symbol, and also the multiplication, very common. And that character is not of the class letter, you see. So that means you cannot use this character in function names in many languages, which is pretty sad. It's a bad decision because we need this, and also this sum. You see, now I'm getting complications. You see that summation. You see this summation character. Now this summation character looks the same as the Greek sigma character, capital sigma, Greek capital sigma. But however, in Unicode, they are distinct, two different characters. So you have one character that's a Greek sigma. Let me show you. Okay. So first of all, copy this to my talk show page so we can read it later. Then let me show you about the Greek sigma. Okay. So let me show you. Okay, hold on a second. So open a new buffer, magnify sigma. This is the Greek sigma, and make it into a Unicode. Okay, wait. Okay, sigma. Okay, so actually, so let's change this to Unicode. Let's change it to Unicode. You see, this is a lowercase sigma. This is a capital case sigma. This is a Greek letter. But however, you have the summation sign. You see, these two characters are different because this one, the Greek capital sigma, we call describe char, and you can see that is that. Okay, let's remove this shit. Okay, code point 9. Okay, let's delete that. You see that character is code point 931. But however, this one, describe char, then it is, you see, this character is code point 8721. So they are completely different characters, but they look the same. So back to our article. So if you want to name a function, sum is a very common mathematical function name, sum. If you want to name your function by the summation character, you can, the proper symbol to use is this character, is this one, not this one. Okay, because this one is actually means summation, but that one, the Greek sigma, that's just a capital letter of Greek sigma. Okay, so they are different. So now, you want to use this sum character, but you cannot do it in Python, you cannot do it in JavaScript. Problem. Why? Because this summation symbol is not a letter. It's not doesn't have the property being a letter. So can you see the complexity? The issues, problems with this design. These fucking nerds. These standards. We need to respect these fucking idiotic standards that we are bequeathed with. That's a issue. So anyway, so this is about some of the complexities of and I have a list actually. So you see, C++, Go, Java, JavaScript, Python, Perl, Ruby, and so on. So do they allow Unicode in name? No, no, yes, 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 no, yes, yes, yes. Do they allow math symbol? No, 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 no. Yes. Ruby, yes. No, no. Emacs, lisp, yes. Julia, yes. Mathematica, yes. Say, do they allow Unicode as do they allow do they allow you to define a new operator? So C no, C++ no, Go no, Java no, JavaScript no, Python yes, you can define your own operator. Perl no, Ruby question I don't know, OCaml yes. So then the next question: do they allow math symbols in operator? If you allow defining an operator, the next question is: do you allow Unicode such as circle plus to be an operator? So you can see here, Python allows you to define operators, but however, you cannot use a Unicode as an operator. So it's like one fuck up, because once a language allows you to define operators, which is extremely useful if you are doing mathematical scientific programming, extremely useful, because you need to define plus and multiplication for vectors, for octonions, for quaternions, for different algebraic things. You need the operator beats the function notation. Operator makes it much easier to read. So if you do scientific programming, you want the ability to define operators, and in general mathematical oriented languages allow that. For example, Julia and Mathematica, you can see in Julia and Mathematica it's all yes. You can see here, you see, in Julia and Mathematica, you can define your own operators, and you can also use a Unicode for your operator. So that's some of the issues. These are the issues about whether you can use a Unicode name in your programming language's function or variable. Okay, that's about that. Okay, so let's delete that. Let's copy that, close that. Let's put it here so we can have a overview of what we talked about today. So how long have I been talking? And let me read the comments. Okay, we have digressed so much. Oh my god, it's 1 hour already. Okay, I guess there's actually a lot to talk about. We haven't begun. What is this? Oh, George is posting something. Well, so okay, we started to talk about Golang, and we digressed into Unicode issues in programming languages. And now I guess we're supposed to return to Golang, because originally I want to show you the thing I want to fix, but because I started to talk about the output of Golang, my Golang script, the first line is about Unicode declaration for the source code, the encoding, then the timestamp, then other information. But anyway, we digressed a lot. Then we digressed into about what are the issues related to Unicode in a programming language. And I mentioned in summary again, there's a source code encoding issue and declaration issue. Then there is a string issue. What is a string? How do you, can you have Unicode in string, and what is a string exactly? Then we have the function name and variable name identifier, Unicode in identifier issue. And I don't think that's all. There is more issues. Let me try if I can summarize quickly. Yeah, and okay, then there is also Unicode escape sequence in string. Like, how do you represent Unicode? You know that. So okay, that's part of the string issue. Okay, yeah, mostly it's about these three issues: Unicode issues in programming language, file encoding, string, the meaning of string, and how do you represent Unicode in string and things like that. Do they have, for some languages you actually have uh, a char that's a Unicode character data type, and in Golang that is called run. So again, I have a page on that. I'm not going to show it, but that's okay. That's it. Let me read the comments then. Dimitri, hey Xah, Happy New Year, Happy New Year to you. Dimitri joined Discord, so I can know you better. So my beautiful face is not moving. What? Oh, Jesus. What's going on? Oh God, I talked for how long? That's a major failure. 3:47. So I talked for 30 minutes without kind of my video. What's going on with the software? Let's see if we can fix it something. Okay, so I talked for 30 minutes without without my face. That's pretty bad. That's depressing. What is the problem? The problem is, I don't know, the video stuck. What the fuck? Okay, that's pretty bad. Okay, that's it for today. Thank you guys for watching. Yeah, that's it for today, I guess. I should have checked the comments more often, but so I've been talking for 30 minutes without looking at the comments. So can you name variables in Chinese using Unicode? Yes, you can. For some of the languages, okay, I have an example here. For example, I show you Golang. You can see identifiers with Greek characters and also a symbol. Oh, that's a syntax error because Golang doesn't allow it. Then you have Python 2, then you have Python 3. In Python 3, yeah, you cannot have arbitrary symbol. That's the symbol you use for function name must be a letter type. and JavaScript is pretty much the same, but you have other more rules. And yes, you can use Chinese because Chinese characters, they belong to the letter property. They have, they belong to the letter categorization. And in Ruby, it's the same thing. They do not allow non-letter Unicode, so you cannot have circle plus. In Perl, everything is allowed. Okay, in Perl. Wait, oh no, it's not allowed neither. Sucks. You see, many of them they do not allow non-letter, but in Emacs Lisp it's allowed. Actually, well, we anyway, it's allowed. Okay, you can just run this code and you'll run. OCaml, it does not even allow any Unicode at all. And Haskell, and you can see Haskell gets fancy. Haskell allows it, but however, that's a recent development in the past few years. Okay, yeah, goodbye guys. That's it for today. So today's topic is about Unicode stuff. Bye guys.